Welcome to Spark Learning session. Today, we'll continue from our last session where we talked about clustering. And this was done for a consulting project where hackers has intercepted a data center in a big, large corporation. And we want to identify how many hackers were there. Now, we'll continue to model selection. So, from your point of view, what kind of model algorithm should we use for clustering for this? Think about it. We'll be using the k-means algorithm for this one. Therefore, I'm going to write k-means here because it is a most easily implemented algorithm and really useful and simple and easily implemented algorithm. That's how we'll use k-means algorithm. You could use k-means too, but it's not necessary to use k-means here because we don't need to have we are not looking for a certain data point that can be a median value. It can be mean also. Therefore, k-means takes more intensive computation than k-means because we need to calculate a point and find every distance between all the points. While in k-means we are trying to find a center itself. So that's why it is much easier to compute k-means than k-means. And we don't need k-means here. We just k-means should be enough. Now, what we need here is the second step is data processing. Let's get started with looking at a data set. Data set is columns and see what inside this set is. Let's run all the codes so that we don't have any errors. And once you run this should show us a list of the columns that exist in the data set. And we have these columns in the data set. Now, we need to define the featured columns that's available that can be used for our analysis. And we're going to type featured columns which will be the list of the columns available in the data set. That is, it's going to be a session connection and it's be session connection time and it is a bytes transfer. These are the columns that are available in the data set, which will be used for except location. We don't need location here because location is not useful for our case because they are using VPN. And when they use VPN, location can be anything. Therefore, it's not actually useful here. Therefore, we'll remove this. Now let's run this. We should create a frame called list called featured columns. Now we'll create an assembler. And to create assembler, we'll use a function called vector assembler that will take the data set, that will take the input columns, and we'll create a assembler called features. Now let's create an assembler here. That will take the input as a feature columns and output column will be the feature vectors. Assembler. Let's run this. This is our assembler. Now we're going to use assembler to modify our data set, which will give us a final data. Now the final data which will be the data will be equal to assembler that transforms the data and will give us a final data. Let's run this. Now, do you know what we should do next? Can you tell me? We should look at the columns now. What columns are available in final data once we run the assembler? This will give us a complete picture of how the final data has been modified by the assembler. Now we'll just look at the final data into print schema and see what's inside the final data here. And yes, we see all the columns, including the features column, which was created by the assembler. Now we'll look at the data and see, just take a peek at the data and see the summary statistics of the final data. As is customary, whenever you are doing this final data, we have always have to do these three things. We have to look at the columns, look at the summary statistics, and a few heads, few rows of the data. That'll make the complete data analysis, complete profiling of data. And these are summary statistics, like here's the 334 rows, mean is 30 for connection time, mean max. This information doesn't look something unusual. Nothing looks unusual. Now we'll look at the few rows of the data, final head, and we'll look at a few rows, like 5 rows of data, and see what's there is populated. And looking at this, nothing seems unusual, and we have this dense vector that is a feature column, and it has been created by the assembler. Now we need to use a scaler to scale the data, because there are some data here that needs to be scaled for our purpose. Since it's a distance-based algorithm, all data has to be scaled to the same scale. No data should be great because it will dominate the distance metric. So all data has to be scaled, and that's why we will use a standard scaler. And input column will be feature column, output column will be scale feature, and this will be the with standard deviation true. And we can just remove these because these are by default. And we'll put like this, and this should give us a scalar that we're going to use. Now what we need to do is we need to fit the scalar on a final data such that we have a scaled model. So what we'll do is create a scalar model that will fit the final data, and we have a scale model. This will give us a scale model of the data, and then we'll use the scale final data, scaled final data, and we'll apply a scale model on a final data to get a scale final data. And as a next step, can you tell me what we should do? We should again look at the columns that has been modified by the scale model. Therefore, we will look at the columns that has been modified by the scalar model and scale final data. How to do that? Can you tell me? We'll use the final data, comma, print schema. This will give the columns that has been modified by the scale data. It's not giving the issue here because I have a spelling error here. It should be SKLE. Therefore, it should be scale data. Scale data. And we have a new column called scale features, and this is exactly what we need. In summary, this is data processing for our k-means model. In summary, what we did today is we look at the data and saw the different columns in the data set. We took the featured columns and removed the location. We created assembler and we applied assembler on data set. And then we do the data profiling using a print schema, data described to generate summary statistics, and looking at a few head rows of the data using head column, head method. And then we use a scaler called standard scaler to scale the data so that we have a scale features on the feature data. So that's all for today. I'll see you next session. Thank you so much.